Okay, guys, in this lesson, we're going to learn to write linear equations from a word problem. We will also graph these equations. First of all, we must remember that we are going to use slope-intercept form, y equals mx plus b, where m is your slope, and in a situation, we call it a constant rate of change. The b value is your y-intercept. And in our word problem, we typically call it the initial value, the value that you start with before things start going up or going down. The x in each situation, the x will be different. The y typically represents the total amount of whatever the situation we are talking about, like total height, total cost, things like that. So let's start out with our first situation. Professor Watson has 12 students pre-register. The registration closes after 7 days. During the registration, the class averages 2 students per day. So we have this course that folks are registering for, and before it even opens, before day 0, 12 students have registered. So 12 is going to be the initial value, our b value. So remember, we're writing an equation y equals mx plus b, and we're filling in the rate of change and the initial value. During the registration, the class averages about 2 students per day. So when you see words such as per or each or every, that really will let you know that that is going to be your constant rate of change. So 2 is our slope, our constant rate of change. So the equation is y equals 2x plus 12. This 7, we don't even need for the equation. It just is telling us that on day 7, registration is over. So our line will stop at the 7. Okay, so our x value, and you can see already, okay, on the x-axis, and you can see it in the problem, which you always will, 2 students per day. So the x value represents the days of registration. The y value is total students that have registered. And again, you can see on the y-axis, we have the label students. So I like to use the word total when I'm referring to the y value. So the total depends on how many folks register. We have 2 per day, so it depends on how many days of registration, which we know is 7. So now we can take this equation and we can answer any kind of questions. So it says on day 5, so day 5, remember X is day, we want to know how many students are registered. So you simply plug in 5 for X and then you evaluate. So Y, total students, 2 times 5 is 10 plus 12 gives us a total of, and I'm going to write it here, 27 students. Now let's graph this. So we're going to locate the y-intercept first, so that's 0, 12. Sometimes you may have to write in some numbers, okay? These are going up by 3s. And now let's locate, like in 1, on day 1, how many students. So we just say 2 times 1 plus 12, so that's 14. So on day 1, there's about 14. Then on day 2, 2 times 2 is 4, plus 12 is 16. And we're just going up 2 each time. On day 3, we have 3 times 2 is 6, plus 12 is 18. On day 4, 2 times 4 is 8, plus 12 is 20. On day 5, 5 times 2, again, you're just plugging in here, 5 times 2 is 10, plus 12 is 22. Day 6, 2 times 6 is 12, plus 12 is 24. And on the last day, 2 times 7 is 14 plus 12. So we have 12 and 14, and that's 26. And we normally would connect the points, but I'm not going to in this case because we're talking about days and students, and we don't have partial students. So by connecting it, you're including every point. If you did, that's okay for now for this course. But you can see it is a line, and it is going up 2 over 1, up 2 over 1, okay? Because we have that constant rate of change, up 2 over 1, up 2 over 1, and so forth. Okay, let's take a look at another example. Ju's bathtub contains 40 gallons of water when filled to the top. The water drains at a rate of 5 gallons per minute. Write the equation. And we're not going to worry about constraints here. Okay, we're just going to write the equation. Again, y equals mx plus b. So the slope here is the 5 gallons per minute, but it drains, so it's going out. So my slope is -5. And how much are we starting? What's the initial amount of water? That is our B, so that is 40. So when we put this together, Y equals -5x plus 40. Now, X is going to represent the minutes that go by. So for each minute, 5 gallons drain from the original 40. So this represents minutes. Now, the Y value is total water, but let's talk about this. Is it the total water in the tub or the total water that's drained? Well, at minute 0, we have 40 gallons in the tub. So these Y values is total water in the tub. And now it's going to drain. Okay, so each minute it goes down by 5. And then we'll be able to see when it reaches this line, our x-axis, it will have no more water in it. At so many minutes, it'll be 0 gallons. Okay, it says how many gallons remain in the tub after 3 minutes. So again, we can use our equation to answer questions. So this gives us -15 plus 40. And when we combine those, we get 25, and it's gallons. So let's go over this. So we can go ahead and plot that one. So these are going up by 5s. So at 3 minutes, we have 25 gallons. So let's start back here. In 1 minute, -5 times 1 is -5, plus 40 is 35. So we can see this is going nicely. We can just go straight down. These numbers were very useful. These were easy to use on the number line. And look, in 8 minutes, there is 0 water in the tub. Now I can connect this because minutes and water, the amount of water, you can have numbers in between. Okay, let's do one last example. The Kinsey Tree Farm planted 3 feet Douglas fir trees. After 1 year, the tree grew 1.5 feet. The trees continue to grow at this rate until they reach 15 feet when they are cut for Christmas trees. So again, we have y equals mx plus b. It says they started out at 3 feet, so that's your b value, the initial value. The rate of change is going to be 1.5 feet per year. So when we write this, we have y equals 1.5 times x plus 3. The x here is 1 feet per year. You can see in the sentence, and also here if you already have on the x-axis, but always be able to pick it out in your equation. So this represents years. And then this is the total height of the tree. So I'm going to say total height is what the y represents. And the question, how long will it take a tree to reach its maximum height? And in the equation, the 15 says until they reach 15 feet tall, so that's height. So this time we had to plug in 15 for the height. And we're looking for time, we're looking for x, so this time we're not evaluating. We are going to solve for x. So I'm solving for x, so I need to subtract out the 3. And then I need to divide. I'm going to come over here so I have more room. So I have 12 equals 1.5x, and we're going to divide by 1.5. And again, we're looking for years, and so we are going to say 8 years is how long it's going to take to reach that maximum height of 15. Okay, so we already know that point. So 8 years is going to be 15, and these are going up by 3. So again, it's good to make sure you know all your values on each axis. So in 8 years, it reaches its maximum height of 15. And at year 0, it was 3 feet tall. And then in year 1, so 1.5 times x is 1.5 plus 3. That's going to be 4.5. And then at 2, 1.5 times 2 is 3. 3 plus 3 is 6. And then I'm just going to skip over and do the 4. You don't have to do each individual one. And actually, you can just draw a line once you get, a few points plotted. And let me make this one a little bit neater. So when we do 1.5 times 4, and then you have to add in the original 3, that gives us, I believe, 9. So it should have been more here. And then I'll go ahead and do it exactly for this one. So then we have 1.5 times 6 plus the original 3, and that gives us 12. So that looks a little bit neater. Okay, so when you're plotting these, you can use your slope, okay, but in this situation for me, I thought it was easier just to plug in some of these x values, and again, you can use a calculator to get at your y values, and then just plot those points. Now, typically a line would just keep going forever, but because we're talking about a situation, our graph is going to end because it says when they reach 15 feet, which took 8 years, they cut them down, so it's not going to continue to grow. And I hope this helps.